So I started with the first story. This is maybe different for many of you, but those who are in physics, those who are in computer science, those who are imaging, I think will appreciate this. So this is about metallurgy or metal casting, essentially a process by which you melt metal and pour it into a mold and then create useful objects. Okay? This story is about that. What used to happen is that I was doing PhD on this topic, and my prof said, no, you have to go to real life and see the stuff. So I used to visit these foundries, and it's incredible. These foundries, when the metal is poured into mold, it's actually a very you can say dramatic event. Okay? And I used to love doing photography, so, and it's a photographic challenge because it's like white hot metal, and the foundry is usually very dark, so its contrast is very contrast ratio is very high. So it's very difficult to photograph that. So it used to challenge. So but you can see these pictures. So I used to do that. Of course, I ended up asking a lot of questions, lot of stupid questions. Why are you doing like this? Why are you doing like that? What is this? What is that? And slowly start understanding this you can say the art and science and technology of metal casting. Okay, and slowly realize that it's actually very big industry. I mean, if you see in this picture, those big red circles are the places where you have more than 100 foundries, a cluster of foundries. So Howrah and near Delhi and near Ahmedabad, and then you have Kolhapur and Coimbatore and so on, places like that. So it is a very major industry, I mean contributing a lot to the in terms of employment and exports and things like that. I realize that if you don't have foundry industry, most of our life as we know will go back maybe a few centuries back. I mean, you name any sector, our transport sector, defense sector, machineries, household goods, even art and crafts and medical devices, they all rely on metal castings. So without this, in fact, they say this is a mother industry because it feeds all other industries. Okay? So when I started looking at that, I started realizing that, hey, these guys have a lot of problems. They talk about, in most of the industries, they talk about ppm, which is parts per million rejections. Whereas in foundries, if you look at 5% means it's like 50,000 parts per million rejection. That's a lot of defects. And if you go deep into that, it's all about physics. Okay, you have flow, you have stress, you have gas evolution, you have heat transfer, but all these phenomena are happening at the same time. So you can analyze one at a time. You can analyze only heat transfer or flow or stress, but even all these things come at the same time, it's not very easy to understand what is happening inside the mold cavity. Okay, and we call it as rocket science for rocket scientists. Okay, so one of the reasons, one of the major defects is that you get these small holes in castings, and this is dangerous. If the part is rotating at a high speed, at high velocity, with the high stresses, a hole can break up into a crack and the whole thing can it can be dangerous. Now why does it happen? Because there is what is called as a hot spot. Okay, that's the point which solidifies last. The point solidifies last is where you get a shrinkage cavity hole. Okay, you can avoid that. You can avoid that by simulating that on a computer, but that's multi-physics. You have to simulate that. Then you can figure out why defect happened. That is called hindsight. But also you can change the design on computer, simulate again, and say, hey, this is how it is. This is how you can prevent it from happening in future. So both hindsight and foresight can happen. So by stroke of luck, I discovered a very efficient method. It was like 500 times faster than existing methods to find where the hotspot is. When I was a student doing PhD at IIT Bangalore, it was by sheer accident. But you have to identify that you're trying to compute something else. I was trying to compute actually center of gravity, but it was finding hotspot, which I did not realize it was hotspot. My prof realized it was a hotspot. And he was walking by and saying, what are you trying to do? Oh, looks like you found a hotspot. I said, what is a hotspot? Okay, that's how we started off. And I didn't tell you how I went to IIS to start with and how I went into this area to start with. Basically I was looking for a project on computer graphics. I was very keen about getting into computer science and computer graphics. So the only project which was offered among all the listed on the board was one had computer graphics for something. I didn't look at what something was. I said whatever it is, I don't care, computer graphics, I am doing that. So it turned out to be computer graphics for metal casting applications. So I found the hotspot, and then as luck would have it, I went to Germany. That was my first flight, was international flight. I simply went from Bangalore to Germany to present my research. Eventually I developed the thing in 3 dimensions. Remember, this was the very first lot of IBM PCs which came in India 1986-87. I learned how to program in 3 dimensions. It was not easy because you can still draw dots on the screen, you have to draw areas and 3 dimensions, so I had to figure out that. And eventually before I left IIC, it was actually commercialized, okay. But it had its own limitations. So once I joined IIT, I still had this dream that can I make a better version of that, a much more comprehensive version of that. So if, as I say, when you desire something very greatly, things come in your way. So I had this student called Ramesh and this senior gentleman called Mohan. They both came. Ramesh said I will program and Mohan said I will fund the development, and so we created the first proper commercial software called autocast. Why autocast? Because it starts with A, so I thought A will get listed first always. And talking about automatically analyzing, it was like a AI kind of program for metal casting, so we did that. The very first couple of licenses were sold to actually foreigners. First went to Japan, the second went to USA, Ford Motor Company. One Professor Kreese, who was kind of my PhD thesis foreign reviewer, he helped me to get a contact in Ford. We went to Ford, installed that, demonstrated that. That was a great experience. So that was I think about in late 90s. And so year after that we started doing different versions. We had version 1 and 2 and 3 and 4, and eventually we could develop much better features. We used to run every September courses for industry with hands-on experience onto that, and I can tell you stories about that. There's one place where we used to do one course. This was in Hosur, near between Bangalore and Chennai, and I remember there was about 80-year-old person who was in the room. We just take computers and put everyone on a computer and say, now we start doing simulation, 3-dimensional simulation. And there was this guy, 80-year-old person, who was sitting on a stool in a corner. So I assumed he was attendant first, and then I was looking around, and then I got a doubt. So I asked him, who are you? He said, I am a participant. I said, why are you not sitting on a computer? He said, no, I can't sit on a computer. So I finally got him, made him sit on the thing. I asked someone to teach him, and he was trying to touch the computer screen. Please remember, this was in 90s or early 2000s. I said, no, this is not a touch screen. Touch screen were not invented yet at that point of time. So I teach him how to move the mouse. I said, move the mouse, click the mouse, then the menu will go, and so on. So he started using that. After a few minutes, he was I was helping others, and I went back and saw he had tears flowing through his eyes. So I thought maybe the brightness is too much, and his first time using computers, right? So I asked people to reduce the brightness. So then he said something in Tamil and I couldn't understand. Then they translated for me, and he said, literally he said that I can now die in peace, because for last 50 years I have been pouring metal into molds. I had no clue what happens once metal goes into the mold, because molds are made of sand, you can't see inside. Now I know what happens inside. So I have stories like that, many stories like that. So this really touches your heart. I mean, you feel that even if one person feels happy about what you created a product, to be able to simulate and create better products and even get an insight, nothing like it. So we were doing that year after year, and finally version 9 happened, and in version 10 I said, I don't want to have version 10, doesn't sound good, let's do something different. So we threw away the entire source code, hundreds of thousands of lines of code. We threw the whole thing away. We changed the language, changed the data structure, which is like a new, you can say, architecture, right? And fortunately again, God was kind. We got 2 beautiful programmers, main guy called Kaustav, and and one guy called Subburaj. So these two guys programmed a new version of AutoCast. We could have called it a different name, but then instead of calling a different name, we thought let's use a brand of AutoCast. But then instead of saying version 10, we said X. So we said AutoCast X or AX for short. It is a different product by itself. This was launched in international conference again, and it did very well. And then something else interesting happened. We had some kind of competition in India. This was a competition from 3 ladies. I call them as Amar Akbar Anthony of Indian scientists in metal casting. None of them were mechanical or metallurgical engineers. One was a computer scientist, one is a mathematician, one is a physics person. And they were in the Regional Research Laboratory, now it is called a CSIR NIST laboratory in Trivandrum, and they had developed a software called virtual casting. So when the senior most of them, Dr. Roshan, she was retiring, she gave me a call and said, Prof, would you like to adopt my baby? So I said, what is it? So he said, virtual casting, why don't you adopt that? You know how to market, you have a brand and your AutoCast, so why don't you take our software and merge it into that? And again it was a godsend for us, because our method of simulation was a quick simulation. Okay, it was doing a job, but it was not able to give values of temperature and velocity and things like that. These people had developed a physics based simulation, proper physics based, Navier-Stokes and all those things. So we were feeling the pinch that we want to give a better solution or a alternative solution also to the users. So when they made a phone call, I said, wow, this is great. We can combine our design strengths and user interface strengths with your physics based simulation strengths. We combined the thing. We created a new module called Flow Plus, and that went into this, and then this was also launched. Fortunately, at the same time, IIT had its own incubator, and I was looking for someone to run this whole thing, and I got a great guy called Lanka, who was into Godrej and other companies. He came and said, I will do your startup. So he came, joined, and then we had this company called 3D Foundry Tech, and that's how this whole thing started off. This was going fine. And then, but then we were getting complaints from industry that, it takes us almost 1 day, 2 days to learn how to use the software, and it also takes, some more days to learn all the features of that. So why do you teach us? Sometimes software was easy to learn, but then they said, how do you know the science part of the whole thing? How do you know what you're doing is right? So then I created this, you can say, a virtual academy called eFoundry, okay, on the cloud. This is actually world's first cloud-based metal casting academy. It has its own cloud-based simulator as well. So you can actually upload a 3D model onto the site, and then you can get quickly on your mobile phone a 3D picture of the simulation of the solidification and temperatures, color-coded temperatures. It had a lot of nice stuff and videos and stuff like that. It became very quickly popular. Actually we crossed about 75,000 visitors in the last few months. This was also good. So you can say that with all this, we were also trying to look at the overall impact, right? So from idea to, did we make an impact? So we found that actually yes, I mean then in terms of the number of times that a foundry was trying to get a casting right, we could reduce it to half, reduce it by more than 70%. The rejections that they had 10, 12, 15%, half of that. Energy savings because of yield. In fact, we calculated that the savings were more than 1500 crores and more than 150 licenses sold to different parts of the country. So you can say that over a period of 20-25 years, starting from a accidental idea during my PhD to several versions of the software and an eFoundry and then this overall impact on the industry, I could have said, wow, good enough, let's relax and retire. Okay. But that didn't happen. There was one day when I had 3 hours nothing to do. Actually it was, my son was writing an entrance examination, and then I had nothing to do there. I didn't have my laptop, I had just my mobile phone, and I just made 15 phone calls to people I knew. These were people who had set up eFoundry cells. They were using eFoundry in their institutions, and these were good people. They were people from all kinds of specializations. There were all kinds of places all over the country, from Jadavpur to Rajkot to, from Kolhapur to Trivandrum, right? And I just made the 15 phone calls and said, we know each other for a long time, but how about working on a mega joint project? a multidisciplinary, multi-institutional project. My good fortune that every one of them said, yes, what should we do together? And I said, okay, I have a dream that we have this beautiful software which can simulate, but why don't we put some hardware together and then put some sensors and analytics together and create a SMART Foundry. I'll tell you in a minute what it would mean to us and why would we be doing that. But I just said, can we not build hardware also? Software plus hardware plus the cloud. And we actually have done that. In the last few months we have put together the first version of this. What it can do is any shape that you can imagine in your mind, which you can create a 3D model on a CAD software, and you can 3D print it using a very low cost 3D printer in plastic. You can convert that into metal in just less than 8 hours. Now there are metal 3D printers, but they cost crores, and a small metal part will cost you a lakh or more than that. The same part I can now produce it for less than 1000 rupees. So from an imagination or a CAD model to a metal part in less than 8 hours for the first part. If you want more parts, I can do it in about less than 1 hour per part at a cost less than 1% of 3D metal. It's actually feasible. We have put a system like that together. What can we use it for? We can use it for things which is not possible by existing systems. You want to have just a few, let's say you want 5-10 pieces of metal parts, complex shapes, small intricate features, but complex shape. You want the part in metal. It is not possible by existing systems at a low cost, of course. We can do that now. What is it going to be useful for? This was a dream I told those 15 people. I said, can we think about a tabletop factory where a 25-year-old with a 25 lakh budget in a 25 square meter space can start his own business. I can put this in every engineering college to get students back to engineering in a sense, and also when they go out of engineering they can actually put this factory and you can start making those parts which no one else can make. So we have shared this knowledge, whether it's eFoundry or this is metal casting or a small booklet called Frequently Asked Questions in Simulation, or all the case studies that we have generated in metal casting. We put them all together.